Welcome to my algebra class. We're on Chapter 7, Section 8, the work problems. In these problems, we're going to use the formula that the amount of work done, your work rate, times the time, how much work you do in a certain amount of time, times the time that you work, equals the total work done. So RT equals W. Your work rate is the fractional part of the job done in a given hour. For example, if it takes John 2 hours to mow the entire lawn, his work rate per hour is 1/2 of the job per hour, 1/2. To finish a job, the sum of the fractional parts have to equal 1. In other words, 1 represents the entire job done. For example, and we're going to use charts again on this one. If Josh can split a cord of wood in 4 days, then his work rate per day is 1/4. And if his father can split a cord in 2 days, his work rate per day is 1/2 of the job done. Now, if they work together, and this is generally where we do these work problems, is two things are working and we want to put them together to get the job done quicker. So the amount of time working together, we don't know that yet, so we'll let that be X. And they're working together, so they'll finish together. So the amount of time they work is the same. So the amount of work done by Josh would be 1/4 X, and the amount of job done by Dad would be 1/2 X. So if I take the amount of work done by Josh, add it to the amount of work done by Dad, I'll have the whole job done, which is 1. So you're going to eliminate your denominator, find your least common denominator, which is 4. So 4 goes into 4 once, that leaves me X. 2 goes into 4 twice, so I'm going to multiply this by 2. And 1 times 4 is 4. Collecting like terms, I get 3X equals 4. Divide by 3, I get X equals 1 1/3. So it's going to take them 1 1/3 hours to get the job done, or 1 hour. And 1/3 of an hour is 20 minutes, 1 hour and 20 minutes. Keeping this equation formula, and we're going to do the word problems on page 328, 5 through 12. So head your paper, skip a line, put your title, skip a line, and we're on number 6. And if you look at the directions on page 329, where they start at, 5 through 8, you're to go back and solve the problems in oral exercises 5 to 8. So number 6 is going to be number 6 in the oral exercises. So we'll make our chart. And in number 6, it says Phil can paint the garage in 12 hours. So we have Phil. And Rick can do it in 10 hours. So we have Rick. And the formula number is work rate times the time equals the work done. So Phil can paint the garage in 12 hours. So his work rate is 1/12 of the job done per hour. Rick can do it in 10 hours, so his work rate per hour is 1/10 of the job done. Together, they work together for 3 hours. How long will it take Rick to finish the job alone? So Rick can, they work together for 3 hours. And then that's the amount of time that Phil and Rick both work for a while. And then Rick's going to get stuck doing the rest of the job. So he's worked 3 hours plus whatever more time it takes for him to finish the job. So that's 3 plus X. Multiplying out 3 times 1/12 is 1/4. And this is 3 plus X over 10. So the amount of work done by Phil plus the amount of work done by Rick has to equal the total job done, which is represented by 1. Get rid of your denominators. The least common denominator would be 20 for 4 and 10. 4 goes into 25, so that's 5. 10 goes into 20, that's times 2, so that'd be plus 6 plus 2x. And 20 times 1 is 20. Collecting like terms, simplifying the left, we get 11 plus 2x equals 20. Subtract 11. 2x equals 9. 20 minus 11. Divide by 2, and x equals 9 halves, or 4.5 hours. It would take 4.5 hours for Rick to finish the rest of the job alone. Problem number 8 is still in the oral exercises. Make your chart. Number 8 says Brett usually takes 50 minutes to groom the horses. After 10 minutes, he is joined by Angela, and they finish grooming in 15 minutes. How long would it have taken Angela working alone? So we know Brett's work rate, if it takes him 50 minutes to groom the horses, his work rate is 1/50th of the job done per minute. And Angela, we don't know her work rate yet. We're trying to find it. So we'd have to put 1 over x. It says after working 10 minutes, he was joined by Angela, and they finished grooming in 15 minutes. So Brett was working 10 minutes plus the 15 minutes he worked with Angela. Angela only worked the 15 minutes. Brett had 10 minutes on her. So if I take 25 times 1 over 50, I get 1/2. And Angela would be 15 times 1x. 1 over x, which would be 15 over x. So the amount of work done by Brett is 1, represented by 1/2, plus the amount of work represented by for Angela is 15 over x, and it equals the job done, which is 1. The least common denominator would be the 2 and the x, so we multiply both sides by 2x. 2 goes into 2x, leaving me just the x, so that's x. X cancels with the 2x, leaving the 2, so that's plus 30. And 1 times 2x is 2x. Getting the x's on one side, subtract x, and we get 30 equals x. So the amount of time that it would take Angela to do the job alone is 30 minutes. Problem number 10, make your chart. Ten says a roofing contract estimates that he can shingle a house in 20 hours, and that his assistant can do it in 30. How long would it take them to shingle the house working together? So the contractor estimates that he can shingle the house in 20 hours. His work rate is 1/20th of the job done per hour. And his assistant can do it in 30 hours, because he has less experience, so his work rate is 1/30th of the job done per hour. They're going to work together, so the time would be the same to get the job done. And the work rate of the contractor is x over 20, and the work rate of the assistant is x over 30. So the amount of work done by the contractor plus the amount of work done by the assistant has to equal the whole job done, which is 1. Get rid of your fractions. The least common denominator would be 60. 20 goes into 63, so that's 3x. 30 goes into 62, so plus 2x equals 1 times 60, 60. So 5x equals 60, divide by 5, and we get that x equals 12, so it would take them 12 hours working together. And problem number 12. Make the chart. "12 says Stan can load his truck in 24 minutes. If his brother helps and it takes them 15 minutes to load the truck. How long does it take Stan's brother working alone?" So we have Stan and we have brother. Stan can load his truck in 24 minutes, so his work rate per minute is 1/24 of the job. His brother helps him, and it takes them a total of 15 minutes together work to load the truck. So we don't know brother's work rate, so that's 1 over x. We know the time it takes them working together, it's 15 minutes. So 15 times 1/24 is 15/24. We could simplify that. That's 3/8. Dividing by 3. Excuse me, that should be 5/8. Get another mistake in here. Dividing by 3. And brother is 15 over x. 15 times 1 over x. So the amount of the work done by Stan is 5/8, plus the amount done by brother is 15 over x, and that equals the whole job done, which is 1. Eliminating the denominator, we need the denominator of 8x. So 8 goes into 8x, leaving me the x. That's 5x. The x's cancel, leaving me the 8. That's 120. Equals 8x. Getting the variable on one side, since the 8x is by itself, we want to keep it that way. So that we subtract the 5x. We have 120 equals 3x. Divide by 3, and we get 40. So brother can do the job by himself in 40 minutes. That concludes the evens. Check the answer key in the back for the odds.